Hello, I would like to introduce to you our mechanical reducer or gearbox that works on magnetic field. This gearbox have two rotors, left one and right one, and they are mechanically detached from each other. This mechanical reducer have ratio 4:1, and it also has a safety slipping function. Just when heavy force will exceed its safe limit, I mean when spinning motion will get out of control, that's when one rotor will slip against the other one. This will save generator from excessive spinning force and overheating. And this is a perfect solution for wind power stations. Now let me demonstrate how this works. Let's hold the left side of the rotor and let's twist the right side of the rotor. As you can see right now, it slips. Now let's hold the right side. As you can see, here's also a slipping moment, but with a different period, which shows us coefficient of reduction. On this side, it's 4 times more than the other side. Now let me demonstrate a coefficient of reduction and to prove that it will equal 4:1. Let's spin the left side of gearbox. I'm going to set up edges parallel to each other. Now you can see the upper edge. Now you can see that we made a full rotation cycle on this side, and on the opposite side it was just quarter way, and that is showing us that we have coefficient of reduction 4:1. You can clearly see that the right side is rotating much slower than the other side. Well, unfortunately, this model that you see right here is not perfect because it was made on 3D printer. We are planning to cast all the parts, which will increase its performance and indicators. As I said before, this mechanical reducer gearbox is perfectly suitable for wind power station. Now, if we will apply this gearbox to our wind power station, we would able to save lots of money on system that rotates wind concentrators, and yet will give us protection from excessive wind speed. It will allow our wind power generator to produce electricity during high windstorm without damaging a generator. This gearbox have not only high efficiency factor up to 97%, which we'll demonstrate a little bit later in this video, but it also don't have the need for maintenance, besides maybe bearings replacement once in 10 years or so. You don't need to heat up oil, which requires energy. You don't need to spend money on oil replacement because simply it has no oil. According to our calculation, within 10 years you don't even have to touch it. Things will run smoothly. This gearbox is assembled out of plastic, steel and neodymium magnets, which cost not that much. A shelf price for this gearbox is around $50 for one piece. Now, if we have to amplify a torque power by 5 times, the self-cost of such a product will grow only within about $20. For wind power station 1 kilowatt and higher, it has appropriate size and appropriate price. Now let's go ahead and run a test on torque and slipping breaking point. This is a digital dynamometer. Here's showing the moment in newtons, the practical force in newtons or kilograms, and here we have 75 millimeters trigger. Accordingly, we are multiplying indicators that are on dynamometer on 75 millimeter converted into meters. We will have torque and slipping point. So let's do this. I'm beginning to rotate it. And here you go. You just saw the gearbox slipped. Let's try to do it one more time. And let's measure the indicators. 2.6, 2.7, 2.8. 2.8 multiplied by 75 millimeters, and we'll receive about 0.21 Newton meters. Now I flipped the gearbox so we can measure the torque on other side. And let's rotate it. As you can see, in order to rotate, I don't have to apply too much force. 12.39, 12.5, and now indicators are falling down. And here you go, the slipping point has broken. Now, as you saw, it kind of shoots back, but when we will connect generator to the system, it should run smoothly without this kind of rough shutting back moment, because here on this test we don't have actual load force that restricts reverse motion. So now we saw that we have here 12.5 and 75 millimeters trigger or lever, so the outcome we'll get is 0.92 newtons. So this is a torque force where our gearbox has its slipping point, although the rotation on our generator will be consistent. And this is to take in consideration that our wind blade's rotating speed is much higher than rotation speed in our generator. Now, so we saw that from one side we had 0.21 on one side and 0.92 from the other side. These different indicators are proving that we have a coefficient of reduction about 4:1. And if we look at physics perspective, if we change rotation 4.5 times by the same number of times, the torque also will change. So everything is appropriate from physics perspective. Thank you for your attention.